Hey guys, it's Miss Boyd, and I hate that I'm not able to be at school today. Unfortunately, my son is sick with a fever, the older one this time, so I'm at home. But I wanted to set you guys up for hopefully a good day of figuring out how to verify trig identities. So a lot of today is going to be spent with you doing some practice problems, but before we do that, we need to finish our list of strategies, and I also need to give you guys a couple of definitions. So let's discuss the strategies that we have already written down. These should be on the side, like on the front board already. But in no particular order. I think I will type so that it'll be neater. These are just things when you're trying to simplify trig functions or like change trig functions into something else. These are things that you could try to do. One of the things that you could do is you can change things to sine and cosine. Like try to put as many things in sine and cosine as you can. And another thing that you could do that we had to do often in problems last class was to get common denominators. And combine expressions. So like if you have two fractions being added, you could get common denominators and put them together. Another thing that we did was we substituted a Pythagorean identity. Y'all, these are the key to a lot of problems. You're going to want to memorize them. There are 3 of them. Please work on memorizing those now. Your test is Wednesday of next week. So you have 1 week to make sure you memorize all the identities and then know how to use these strategies to verify problems, okay? And I know you can do it. So sometimes you might see like a trig squared. So if you see a trig squared, like sine squared, and then you also see a 1, that is a pretty good clue that you are going to need to use a trig identity. Sorry, I'm trying to like make a little more space here so that this is less awkward looking. There we go. So especially if you see a trig squared and a 1, it would be a good idea to substitute a Pythagorean identity. And then there were some things that we talked about yesterday. So one of the things that we did was we factored out a GCF. And I think that might be where we left off yesterday. And so there are actually at least 2 or 3 more things that you could do. I'm realizing I'm having typos, sorry. So you could factor out a greatest common factor. If you see that there's something that they have in common, I don't know if this helps you to think of it, but like undistribute is totally not a word, as you can see by the little red lines. But essentially you're taking out a GCF means you're like undistributing something, you're pulling it apart. Okay, so another strategy is actually to factor. And you probably saw this in your homework and you might have been like, what is happening? Because we didn't get to it. But my clue for these factoring ones is to just like for a moment, pretend that the trig function is just an x. So you could like rewrite this as x squared minus 1. You might remember that when you factor x squared minus 1, that's going to be x minus 1 and x plus 1. So if I'm trying to factor secant squared minus 1, it's going to be secant theta minus 1, secant theta plus 1. Okay, that's how you would factor that expression. Now B, I'm going to write down here and extend the page so I have a little more space. B is doubly funky and fun because it has 3 terms, so it's a trinomial, but also you have this hint here. When you're factoring, you need to make sure you have the same trig ratio. Here is where those Pythagorean identities are going to be really helpful. Okay, I can't just replace this with like that. I can't say this is x squared minus x minus 3 because it's not, because like cotangent and cosecant are not the same thing. So I can't do that. I'm going to undo. Oh, I undid too far. Okay. But what I can do is maybe look at my identities. So this is just like a little note off to the side. And think to yourself, like, do I have an identity that has cosecant and also cotangent in it? And it turns out you do. There is an identity that's cotangent squared plus 1 equals cosecant squared. That's one of the Pythagorean identities. So that means since cosecant actually equals this, I can just replace, and I should say cosecant squared. So since cosecant squared equals cotangent squared plus 1, I can replace this cosecant squared with cotangent squared plus 1. Okay, so notice I'm just replacing the thing I underlined in red with the other thing I underlined in red. And now I'm going to bring all the rest of this down. Okay, here is where we're going to combine like terms. So the only like terms I see are the 1 and the 3. Because I can't actually combine these because this has a squared and this does not. So I'm going to have cotangent squared of x minus the cotangent of x. I'm just bringing those down. And then I had 1 minus 3, so that's going to give me minus 2. Okay. Some people can just jump straight to the factoring and they have no problem with that. Other times people just like weirds them out and they're like, I don't know what to do. And so I like encourage people to just like off to the side, rewrite this problem with regular variables instead of trig. So if I asked you to factor x squared minus x minus 2, I bet you could do it. I'm going to have an x and then an x. And then I need two numbers that multiply to -2 but add to -1. So that's going to be -2 and +1. So this is the factored version of this, which means I can kind of do the same thing over here. But instead of writing x minus 2, x plus 1, I'm going to replace it with cotangent. So I'm going to have cotangent x minus 2, cotangent x minus 1. And that is how you factor. If you got stuck on any of the homework questions, I happened to work out 3 of them, and they're in the folder for today. You can see those 3 problems worked out. At least one of them was a factoring problem. And so if you got stuck, I totally understand why, because we hadn't done this yet. So I'm going to go back to our strategies real quick. Maybe. Yes. And add the strategy of just factoring, like plain old factor. Okay, that's something you might have to do. And then there's one strategy that is more obscure than the other ones. All of these, and actually there's one more I think I would like to add that might come up in one of your examples today. If you divide fractions, this is just like a common rule that you have known since elementary school probably. But if you divide fractions, remember that you can multiply the reciprocal of the denominator. Some of you might say keep, change, flip. That's fine. I don't really like keep, change, flip because a lot of times people forget what they're keeping and changing and flipping and what that even means. So I kind of prefer just like the mathy words, multiply the reciprocal of the denominator. But it's cool. Do what you remember. But this is something that happens sometimes. You might have 2 fractions being divided and you can simplify it by multiplying the reciprocal. So our last strategy is one that is not one that I would expect you to get on your own. Like I would definitely need to show it to you. And it involves this thing called the conjugate. So here's what a conjugate is. I had my 5th period actually write this in your notebook. And so it might not be a bad idea for you to pause this video and in your spiral notebook, add this little definition. If the word definition is like not helpful to you, maybe just put some examples of conjugates. So basically it's when you have 2 binomials, and a binomial is like a plus b. And the first term stays the same, and the second term is opposite. So like if a plus b was the first one, then a minus b would be its conjugate. Okay, so x minus 1 is a conjugate with x plus 1. You keep the first term the same, so even though this has a negative sign in front of the 2, it's going to stay. So you have negative 2 plus 3, then you'd have negative 2 minus 3. Those are conjugates. Apples minus oranges and apples plus oranges. These are conjugates. Okay, so to show you why conjugates are helpful, I think I just need to show you an example, because at first it's like, okay, why do I care about a conjugate? It's actually very cool. Let me show you. Here. Okay, so I'm going ahead and asking you to rewrite this by multiplying a conjugate, and I know that it's going to equal this, which is kind of wonky, but it's okay. I gave you the hint of the conjugate. Since I have a 1 plus sign, the conjugate would be 1 minus sign. And we have to be mathematically and algebraically correct here. And so if I multiply 1 minus sign on the denominator, I need to also multiply it on the numerator. Okay, so there is me multiplying it in the numerator. I'm going to leave the numerator, like 1 times 1 minus sign is just 1 minus sign. For the denominator, when I multiply this all the way out, multiply those two, and I multiply these two, this beautiful thing happens where the middle terms cancel out. Like you're essentially going to get a 1 minus sign, and then you're going to get a plus sign, and then you're going to get a minus sign squared. I'm kind of running out of space. And so this middle term of like negative sign and positive sign end up canceling out. And so you're going to get 1 minus sine x, that's the numerator, that doesn't change. But the denominator is going to be 1 minus sine squared x. Okay. Which is beautiful. Here's why this is helpful. Let's make a little note off to the side. Remember our friend's Pythagorean identity. I'm writing up here in the corner, by the way. This was the main Pythagorean identity that you need to know. Well, you need to know all 3 of them, honestly. You need to know all 3 of them, but this one is used the most. You're actually allowed to rearrange a Pythagorean identity however you would like to. Like it's going to stay true as long as you follow the rules of algebra. So notice how my problem over here says 1 minus sine squared. So over here, if I wanted to make it match, I would need to subtract the sine squared over, and I would get cosine squared equals 1 minus sine squared. Yay! So that means I can replace 1 minus sine squared with cosine squared. So back to my problem. My numerator has not changed. My denominator is now going to be cosine squared. And honestly, this is usually where the problem stops. This is kind of funky. I like it though, so I'm going to continue the problem, but I feel like a lot of times this is where it stops. Okay, I ran out of space, so bear with me. And I realize this is long. Some of these problems are long. That's just how they are, and it's okay. You're gonna be better mathematicians for it. Okay, so you know how when we get common denominators, we put the numerators together? It is actually also allowed to pull apart fractions. So I can like since both of these are over cosine squared, I could rewrite it as 1 over cosine squared and then sine over cosine squared. Like we've been a little bit more used to seeing the green and then changing it to the black. But it actually is okay to go from the black writing to the green writing. And then I'm hoping you might notice something. Ultimately, I'm trying to get to this. The reason why I knew to separate them was because I noticed that the answer had a minus sign in it, like it had them pulled apart. So now I kind of need to use some identities to replace. 1 over cosine squared is the same thing as secant squared. And I'm really showing every single step here. But sine over cosine is tangent. So if I could kind of take a sine over cosine, like split it out of this, that would help me. So sine over cosine squared is the same thing as sine over cosine times 1 over cosine. Like I basically just split the cosine squared up. And so I end up with secant squared x minus tangent x secant x. Notice that this is tangent and this is secant. And now we do a strategy that we talked about on Monday, which was taking out a GCF. Notice that this term has a secant in it and this term has a secant in it. So I'm going to use my non-math word, which is undistribute. I'm going to undistribute, i.e. factor, out a secant x. So if I divide a secant x out, I'm going to have a secant x and a tangent x. And notice that this is what they wanted me to have right here. Okay, so here's the thing. I recognize that problem is really long. That's a doozy, honestly. Like, I feel like that's potentially a level 4 question right there. Okay. Like if they just asked you to make it equal this. But the important part of this example was that you see how to do a conjugate. So if you notice like a 1 plus sign or a 1 minus sign, 1 plus cosine, 1 minus cosine, those are big like clues that you should do a conjugate. So I'm going to go back to our list of strategies, and I would love for you in your notebook to make sure that you have all of these strategies written down, because all of these are helpful. And essentially, they're just giving you ideas of things to try when you were trying to verify identities. So if you found the homework challenging because you weren't sure when to stop, like when you were fully simplified, you're like, I don't know when I'm simplified. That is a very valid point. And I'm actually not going to give you a test question that asks you to simplify. What I will do instead is ask you guys to verify. So for example, the problem that we just did, I could give you this, I'm putting a box around it, and ask you to verify this. So I'm telling you what I want it to equal. So it's not just like there's one answer you can show. You're actually proving this. And the way you're proving it is by working on one side only, okay? So you could either work on the right side and try to do some transformations, or not transformations, but you know, like substitutions and multiplication and stuff like that to turn it into the left side. Or you could work with the left side and try to turn it into the right side. You cannot move stuff from one side to the other side. And you also can't work on the left side and then also work on the right side. You have to just like pick one side to work on. Okay? So you just pick one side to work on. Okay, that's it. So here's the plan. In today's folder, you're going to go to the lesson page. It says lesson 3.3, verifying identities. In that folder, there's a PowerPoint of problems. I can't remember how many there are, maybe about 13. And I want you to actually work through those problems on a piece of paper. If we had been in person, if I had been there, I would have had y'all do these on the whiteboards with your group mates. Obviously, since I'm not there, I'm not going to make you do the whiteboard thing, but I would really like you to work together, because this is one of those things where some of you guys are going to see it immediately, some of you aren't. Some of y'all are going to like know how to do number 1 and not number 5, and then somebody else in your group is going to know how to do number 5 and not number 2. You know, like it would be really, really good for you guys to work together on these problems. And then I actually am going to, like, there's going to be a video in that same folder that Mr. Yosef made. So Mr. Yosef actually already made a video going over all of these problems. So I'm really wanting you to like try the problem yourself before you watch Mr. Yosef's video, because this is one of those things that I swear you can just like, when you watch it, you're like, oh yeah, I totally get this. And then when you try to do it on your own, you're like, what? So I need you to try it on your own. I need you to try it on your own, slash with your group. Like I want you to work on it with each other and like talk to each other about it. And then when you get stuck on a problem, you can go to Mr. Yosef's video and like fast forward to the problem that you need to go over. Okay. So that's going to be in the folder for today that says lesson 3.3, verifying identities. And then if you have any extra time, you can go ahead and start working on your homework, and that would be totally fine. One thing that is a huge bummer is, unfortunately, at the moment, I'm probably going to be out on Thursday as well, because I was already planning to be out on Thursday because Mr. Yosef and Mr. Gamble and I are taking a planning day to prepare just the rest of quarter 2 for pre-calculus. That means that Thursday is going to be another practice day. So we're basically just practicing. There's nothing new to learn at this point. You just have to kind of like practice verifying. And y'all, it's going to be hard at first, and that is okay, I swear. It is really normal for it to be confusing and then for it to eventually click. My 5th period yesterday had a lot of people that like partway through class it like completely clicked, and they were like really vibing and they were really enjoying it. So I hope that that is the case for you guys as well. And I would be delighted to answer questions if you would like to email me or send me a Schoology message. So please look in today's folder for the lesson, go to the PowerPoint, work the problems out, and if you need to, watch Mr. Yosef's video. Thanks, guys.